Good morning, students. Once again, I welcome you all to my channel. In this class, I'm going to discuss about features of 8086 microprocessor. In previous class, I gave a brief introduction about microprocessors. And this second lecture, I'm going to discuss about features of 8086 microprocessor. Introduction to 8086. 8086 microprocessor is an enhanced version of 8085 microprocessor. It was designed by Intel Corporation in the year 1978. It was designed by using HMAS technology. HMAS means high speed or high density technology. It contains total 29,000 of transistors. And it was available in 3 different versions. Those are 8086, 8086_1, and 8086_2. Come to the first point. 8086 microprocessor is enhanced version of 8085. Here my intention is enhanced in the sense the speed of operation of 8086 is more than 8085. In terms of speed, 8086 have enhanced speed compared to 8085. The functions which are performed by 8086 was more compared to 8085. We know that 8085 was an 8-bit microprocessor from Intel, and 8086 was a 16-bit processor from Intel. The second thing is, this 8086 processor was designed by using HMAS technology. That means high speed or high density mass technology. But go to 8085, it is an 8-bit processor. It was designed by using NMOS technology. And the number of transistors are incorporated in 8086 processor was 29,000 of transistors. And it was available in 3 different versions with the different clock frequencies. Next, I straight away enter to the features of 8086. The first one is, it is a 16-bit processor. Here, the meaning of the 16-bit is, the word length of this processor is 16-bit. That means it can do the arithmetic and logical operations maximum on 16-bit. It means it indirectly speaks about the capacity of ALU. And also at a time it can transfer 16 bits. And as well as it can also receive at a time 16 bits at maximum. So that it is called a 16-bit processor. And it is its word length is a 16-bit. That is the meaning of a first point. Coming to the second feature is, it has a 16 data lines D15 to D0 and 20 address lines, that is a 20-bit address bus A19 to A0. All data lines are multiplexed with lower order 16 address lines A15 to A0. The multiplex bus here is AD15 to AD0. And similarly, we have higher order 4 address lines A19 to A16. These are multiplexed with the 4 status lines A6 to A3. The multiplexed bus is A19/S62, A16/S3. Here the multiplexing is a time division multiplexing. That means one time incident, these lines are act as address lines. In some other time incident, these signals are act as a data lines as well as status lines. Most of your processors and controllers, we identify this multiplexing concept. The main reason behind using a multiplexing concept is in order to reduce the number of pins or signals are available in the processor IC. If you are not doing this multiplexing, the number of signals present in the IC was increases. Once it was increases, automatically the processor occupied space on the PCB also increases. And also it consumes more power. So that most of the cases, we preferably use the multiplexing concept between the signals. And one more thing is, all processor may not use this multiplexing process. The major disadvantage of using multiplexing concept in our processor is the speed of operation of the system is reduces. If you consider this particular case, multiplexing of address and data lines, in one time instant, these lines are act as an address lines. In some other time instant, these signals are act as data lines. So that at a time, we were unable to transfer data and address simultaneously. If you have a dedicated lines, we can do this simultaneously. That means at a time, I'll transfer an address as well as data. Then the speed of operation of the system is increases. Because of this reason, in all processors and controllers, we won't go with multiplexing concept. The next point is it supports 1 megabyte of memory. That means by using 20 address lines of the processor, we can able to address the memory of size 1 MB because 2 power 20 is equal to 1 MB. That 1 megabyte of memory can be divided into 16 logical segments. Each segment size is equal to 64 kilobytes. That means 1 MB of memory not physically divided. It is only logically divided into 16 segments. Each segment size is equal to 64 kilobytes. Why we are going for a segmentation? For that, we have so many advantages by using of segmentation concept. In later classes, I'll go and discuss the advantages of utilization of segmentation in 8086 processor-based systems. And next, coming to the operating clock frequencies of 8086. In introduction part, I told you that there are 3 versions of 8086 processor was available. Those are 8086. Second one is 8086_1. Third one is 8086_2. These are the 3 different versions. These are 3 different versions have 3 different frequencies. If you go for simple 8086 processor, its operating clock frequency is 5 megahertz. For 8086_1, operating frequency is 10 megahertz. For 8086_2, its operating clock frequency is 8 megahertz. The speed of operation of the processor is out and out is depends on operating clock frequency. You know that. Because there is a relation between a frequency and a time period. T is equal to 1 by F. If the frequency increases, automatically the time period should be reduces. Coming to another feature, it has a 6 bytes of instruction prefetch queue. That means in the internal structure of 8086 processor, there was an instruction prefetch queue. The name itself indicates prefetch queue. That means it can hold the 6 bytes of instruction ahead of their execution, so that the execution can be done in a faster way. So that is the use of this prefetch queue. And one more important thing is the instruction set of 8086 contains variable length instructions because your 8086 comes under CISC processor. We know that the feature of this processor is complex instruction set computer is the instruction set contains more number of instructions. That means to do each and every operation, there was a dedicated instruction. If that operation we performed regular basis or occasional basis, but there was a dedicated instruction to do each and every operation, so that the number of instructions present in the instruction set was more. If you consider 8086 instruction set, a minimum size of an instruction is 1 byte and a maximum size of an instruction is 6 bytes. And the next one is it supports 2 hardware interrupts and 256 software interrupts. Here 2 hardware interrupts means your 8086 can receive hardware interrupts from external I/O devices with the help of 2 signals. Here the 2 hardware interrupts means the hardware interrupts are related to the interrupts are generated by I/O devices. And here the 2 indicates it is not the interrupt signals are generated by 2 devices. The meaning of here 2 is the hardware's interrupts are received by the processor with the help of 2 signals. We know that one signal is called INTR, interrupt request, and another signal is called non-maskable interrupt signal, NMI. By using these 2 signals, our processor can receive interrupts from external I/O devices. And coming to the second one is 256 software interrupts. That means the interrupts are generated by execution of some dedicated instructions. For generation of these 256 interrupts, we are using 256 instructions. The instruction looks like INTN, where N value is from 00H to FFH. There are 256 software interrupts we generated with the help of instructions INT00H2, INTFFH. The next one is our 8086 can operate in two different modes. One mode of operation is called a minimum mode. It is also called a single processor mode. And another type of mode of operation of processor is maximum mode, and it is also called multiprocessor mode. This type of operation we never identified previous to 8086. So in a minimum mode, it is also called single processor mode. If your system contains only one processor was present, that processor is whole and responsible for the operations are performed on the systems. But coming to the second one, maximum mode or multiprocessor mode, the system contains more than one processor. Along with your 8086, they have a different co-processors also present. Those processors also may use a system bus. Here, the operations performed on the system bus is not in the hands of any single processor. It is in the hands of a dedicated hardware called bus controller 8288. Later, we'll go and discuss much more about these two modes of operations of 8086. And next one is it contains 14 16-bit registers. Here, what are the 14 16-bit registers I mentioned in these features? Those are user accessible registers. That means user can use these registers in his or in her programming. Along with this 14 16-bit registers, your 8086 may also have another group of registers. Those are called machine accessible registers, MERs. The examples for machine accessible registers are instruction register IR, memory address register MER, memory data register MDR, input output address register IOR, input output buffer register IOBR. Like this, there are different machine accessible registers also available in our 8086. Along with this 14 16-bit registers comes under user accessible. And the next one is this processor was available in 40-pin dual inline package. That means this processor have total 40 pins or 40 signals or 40 lines. With the help of these lines, our processor can interacting with external world. That means with the help of those signals, the processor can interacting with the memory elements as well as an IO devices. And coming to the last point, it has a 9 active flags. Those are 9 active flags. Again, we furtherly classify them into two groups. The first group are called conditional flags or status flags. Their count was 6. And another group is control flags. Their count was 3. I give a little bit information here regarding to conditional flags as well as control flags. The conditional flags we can also call the mathematical flags. These flags set and reset conditions are happened with respect to the result was produced by ALU. That means the ALU can do different arithmetic and logical operations. While it was performing that, when it was producing a result, along with that result, it can produce certain conditions of a result. Those conditions of a result were stored in this conditional flags or status flags or mathematical flags. These are basically 6. These 6 flags are: one is sign flag, second one is a zero flag, third one is auxiliary carry, fourth one is parity, fifth one is carry, and the sixth one is OR. These flags set and reset conditions out and out or depends on the results produced by ALU. So that these are called conditional flags. And the second category of flags we are calling as control flags. These flags set and reset conditions influence the processor operation. In this category, there are 3 flags. One is a direction flag, second one is a trap flag, and third one is interrupt flag. These flags set and reset conditions influence the processor operation. And one more point here I would like to add. For this 8086, there are 2 coprocessors. One coprocessor is 8087, which is called arithmetic coprocessor or math coprocessor to 8086. That 8087 can do different arithmetic and logical operations which are assigned by our 8086. And one more is 8089, which is input-output processor for our 8086. In order to reduce the burden on your 8086, we took the help of these 2 coprocessors. One is a math coprocessor 8087, and another one is an input-output coprocessor 8089. These are two are reduced burden on 8086 while doing of arithmetic and logical operations as well as doing of input and output operations. These are the some of the features of 8051 microcontroller. Sorry, 8086 microprocessor. Thank you for patient listening. We'll meet you in the next class. Thank you very much once again.